Okay, geometry class, welcome back to our unit on volume. So anyway, we have our first video already done. We talked about volume of prisms, volume of cylinders, volume of composite figures. And now for this lesson, we're going to learn about volume of pyramids and cones. So we're going to have a couple of different formulas on our hands, but it'll be fun nonetheless. Before we do, let's do a quick review on the concept involving units of measure. We have to remember when we talk about volume, it's important to recall units of measure. In one dimension, we have just one dimension. We're dealing with just plain old units, centimeters, meters, yards, feet. And those are things for like distance or length or perimeter or circumference. That's one dimension, so it's straight up units. Then we got into two dimensions, what we called area. And our units of measure for area involved squared centimeters, squared meters, squared yards, and squared feet. And then we went into volume, third dimension. And so when we talk about three dimensions, we talk about volume, we must use cubic centimeters, cubic meters, cubic yards, and cubic feet. So that's our quick review piece. And now let's talk about the volume of pyramids and cones. So the first formula we're going to visit is the volume of a pyramid. Just like similar to volume of a prism, where we had the area of the base times the height, we have a volume of a pyramid, which is awfully similar, but we have now a 1/3. So when we're talking about volumes of pyramids and cones, we want to revisit, we're talking about 1/3 the area of the base times the height. So just like with prisms and cylinders, we have our base, we can find the area of our base, and we have a height of our pyramid from the top perpendicular to the base. Now, for this note, I want to draw the difference between our height and slant height. So remember from surface area, there exists a thing called slant height, and we have to be cautious about that. So for the case of volume, we want the height, not the slant height, okay? So it's very similar, but now we're dealing with 1/3 the area of the base times the height. That's our volume of a pyramid. We also have the volume of a cone, which, as you guessed it, is the same formula. Now, we might look at this crazy formula, and we can see, oh my goodness, there's this whole thing. That's simply the area of the base. Our base is a circle, so the area is pi r squared. So it's, again, 1/3 area of the base times the height. It's the same thing for a cone. I want to make sure that we are clear on that. It's the same thing. 1/3 area of the base times the height. And again, seeing the difference between height and slant height. Okay, so we have to draw a couple of those differences as we move along. So that's it for the notes. The rest is examples. Let's see how this looks in problems. So I'm going to hit you with a word problem right away. You're going to freak out. Oh no, Mr. Katz, it's a word problem. Just read, you'll be fine. A sports arena is shaped like a pyramid. That's useful information. Has a base area of about 300,000 square feet and a height of 321 feet. That's useful information. What's the approximate volume of the arena? So recall the quick formula we just learned. Volume is 1/3 area of the base times the height. So we have to recall that quick thing, and then we realize this word problem is harmless as a cute fuzzy puppy because it gives us everything we need. Check it out. We need the area of the base, and look what it tells us. The base area, 300,000 square feet. We got it. We also need for the volume a height, and look what the word problem gives us. A height of 321 feet. We have it right there. It's no big deal. So we have everything we need. All we gotta do, put it together. We'll see how that 1/3 looks. So volume is 1/3 of the area of the base, 300,000 square feet, and times the height, which is 321 feet. So the rest is calculator work, right? Right, so you grab your calculator, you start to push some buttons. I'm going to say, whoa, time out. Don't use your calculator yet because you can do this without a calculator. Let's see how. Look what's going on. We are calculating 1/3 of 300,000. Come on, man, you got this. 1/3 of 300,000? That's 100,000, right? Right. So, okay, now it's 100,000 times 321, right, calculator? No, 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 no. We got this, you got this, you got this. So check this out. How are we going to multiply that big number? Well, we write down 321, and then count your zeros. 1, 2, 3, 4, 5 zeros, because times 1, right? So 1, 2, 3, 4, 5 zeros. All we have to do is know our place value and kick it backwards. Every 3 zeros is a comma for your thousands, and every 3 zeros is a comma for your 100,000s, and we can see that we're working in millions. So this is about 32 million. So we got to remember place value and how that works, but 32 million what? We're dealing with volume, and we're talking about feet, and so we're looking at 32 million cubic feet. 32 million cubic feet. So depending on how your answer is wanted, just make sure that we are using cubic feet. So that's how these examples work. Nothing big, right? Right. Okay. Let's take a road trip, shall we? To France. Vive la France! So the entrance to the Louvre Museum in Paris is a square pyramid. Useful information. With a height of 21.64 meters, useful information. What's the approximate volume of the Louvre pyramid? So we're dealing with volume. Once again, that formula we just learned. Volume, 1/3 the area of the base times the height. All we need to do now is a little bit of thinking. We've done worse. We need the area of the base, but this is a square pyramid. So that's useful. We're just missing a bit of information until we look at the picture. Pay attention. Whoa, right there. 35.4 meters is one of the lengths of the base, so we can easily find the area of the base. Area of that base, 35.4 squared. That's how easy that works. So that's how we calculate the area of the base. Base times height, right? So 35.4 times 35.4, that's going to give you the area of the base. We got it. And then we needed the height for the volume, but the height is given to us in the problem itself. So this is another could have been worse problem. We have everything we need. So the volume is 1/3 the area of the base, which is 35.4 squared, and then times the height, 21.64. Now the rest is calculator work. Okay, so this is where we can use our handy dandy tool. So we have our tool ready to go, and we just calculated 35.4, square that, and then we're going to multiply that by 21.64 equals, and then we're going to divide that by 3. 1/3 divided by 3 equals. Okay, so we have our figure here. It's a weird one. So we have a 9, a 0, a 3, a 9, a point, a 4, a 6. So we'll leave it there. 9,039.46 something, right? And so all we have to do now is check the directions. How do we want it? It's wanted as approximate. And so we'll say, 9,000, but 9,000 what? This is dealing with meters, and so the volume is going to be cubic meters. 9,000 cubic meters. So depending on how the answer is wanted, if it's rounded to something, we could use that. If it's about, we could use that. So either way, we can figure out how the units are wanted. All right, so there's that one. Now for another example, let's see if you can figure this one out. We have a square pyramid. Again, some useful information. A square pyramid. And it has base edges of 24 meters, and this time a slant height of 13 meters. So we have to remember from the notes, there's a difference between height and slant height. Okay, remember the slant height and our height. So at least we know one thing. We know we're dealing with volume, and so volume is 1/3 the area of the base times the height. The area of the base is the easy part, right? Because it's a square pyramid. 24 by 24, no sweat, we got that. It's the height that's a problem. So we're going to bring back a concept that we learned back in area of regular polygons called the pop-out triangle. So let's pop out that right triangle so we can study it a bit. Okay, so we have a right triangle here. we know we're missing our height. There's the height, and we know that the slant height is 13 meters. 13 meters. Now the only question becomes, do we know this distance, right? Is this a distance that we know? And the answer is yes, it is, because the entire base is 24 meters. So in our little triangle that we're studying, since it's a square pyramid, the triangle we're studying, it's going to be half of that distance. And so we know this is going to be 12 meters. And then we can have Pythagoras lead us the way from here. And remember what Pythagoras said. The sum of the squares of the bases, or the legs of any right triangle, is equal to the square of the hypotenuse of that right triangle. And so Pythagoras is there to help us, and we can trust with him. Now, in the setup like this, when we have the hypotenuse, remember we will be subtracting in order to find our missing value. So from our setup here, we can use our calculator and, 13 squared minus 12 squared, because remember we're subtracting, and then we take the square root of what's left, and then we have a pretty number. We find out that the height is 5. Now, we could have avoided that had we known some Pythagorean triples, the old 5, 12, 13. The old 5, 12, 13 right triangle. But it's a Pythagorean triple, we should know that. But if not, we can figure it out later. So anyway, we have found the height, we have found our missing value, and we now know everything. Okay, so the area of our base, since it's a square pyramid, 24 by 24, we now know our height that we just found is 5. So the rest is some crunch work, right? No big deal. So the volume is 1/3 the area of the base, which is 24 square meters, and times the height, which again we found at 5. So we have everything we need set up here, and now it all depends on the answer. Okay, so how do we want it, round it, or whatever, but we don't need to worry about rounding because 24 is divisible by 3, and that's just useful information. So if we're going to be able to divide by 3, our 1/3 are not very scary at all. So how do we do that with the calculator? Pretty simple. 24 squared times 5, and then we have a number, we divide that by 3, and we know it will be divisible. 960. Okay, but 960 what? Meters. So 960 cubic meters for volume. And that's how the volume of pyramids work. Okay, no big deal. In the next example, we're now talking about cones. So we have to read a little bit. The covering on a teepee rests on poles that come together like concurrent lines. What? You don't even have to know what any of that means. You may have never heard of a teepee. That's fine. You may not understand what any of this means. That's fine. What's important is the next sentence. The resulting structure approximates a cone. So now we know we're looking at a cone. And you remember if you don't know the teepee, the Native American living dwelling, sticks come together and they put the canvas around it. Anyway, it's a nice little tent. But that's not important. What's important is we know that we have a figure that is approximating a cone. If the teepee picture, not pictured with a picture, but in your head, is 12 feet high, that's useful. That's a height. With a base diameter of 14 feet, what is the approximate volume? Okay, so again, we're dealing with volume. And I know that we're dealing with a cone, but we're still looking at the same type of thing, okay? The volume is the 1/3 the area of the base, but in this case, the base is a circle, okay? The base is a circle. And we have to remember the area of a circle is pi times the radius squared. And if the diameter of that circle is 14 feet, that means the radius is going to be 7. So the area of our base in this question is pi times the radius squared, or 49 pi. So all of that thinking from the area of the base, we have to keep that in mind. The height of the teepee is super simple. It gives us to us is 12 feet high. Okay, so even though we're dealing with a cone, it's just circle stuff, and we're all set to go. the volume is equal to 1/3. We have the area of the base, 49 pi, and we have the height, it's 12 feet high. So we're all set. Now the only question becomes, how do you want this answer? Because we can give you this answer in a couple different ways. If we want an exact value, or in terms of pi, it's quite simple. 1/3 of 12 is 4, okay? So if we want it in terms of pi, 1/3 of 12 is 4. All we have to do is multiply 49 times 12 is equal to whatever that is, divide by 3. It's going to give us a nice, pretty number. It's 196, but in terms of pi. So it's 196 pi. So if we wanted exact values, it would be 196 pi cubic feet. If we wanted an estimate or rounded, okay, which is what this particular problem wants, it'd be the same type of thing. 49 times pi times 12 is equal to whatever. Divide that by 3, 615.75. Okay, so whatever that turns out to be, 615.75 cubic feet. And that's however, this says approximate, so we can come close, 600 cubic feet, whatever we want to say. So once we have our formula set up, the rest is just, hey, how are we using the calculator in this example? How's it going to work? Not that big of a deal. Okay, one last example, and we'll call it a day. So then we're going to work with another cone, and we're going to scare ourselves a little bit. It's like, oh no, this cone, it looks kind of weird because it's what's called an oblique cone. That's what this word is, oblique. It's called an oblique cone, and it looks scary because it looks tilted. I don't know what to do. No, it's chill out, man. We're still talking about volume of a cone. And volume of a cone is still 1/3 area of the base times the height. So no sweat, no sweat, no sweat. Area of the base, remember, is pi times the radius squared. This base has a diameter of 30 feet. Therefore, the radius is going to be 15 feet. So the area of the base is going to be pi times the radius squared. It's not that big of a deal. The height is simple to see. It's right there. It's 25 feet. Okay, so this is not the most challenging thing we've ever experienced. So volume takes care of itself. It's 1/3 the area of the base, which we know 15 times 15 times pi times the height, 25. So we're all set to go. All we have to do now is divide by 3, depending on the answer. Now this tells us two things, right? This question gives two things. We want the answer in terms of pi and also rounded to the nearest foot. So we want our exact value in terms of pi. So that means we just ignore pi, right? Let's do some calculator work. Is it going to be a pretty number? Yes, it is. How do we know? Because 15 is divisible by 3. So at least we know we're going to deal with a pretty number. So we have 15 squared times 25, and then we divide that by 3. 1,875 pi's, right? So we're talking about in terms of pi. So it's 1,875 pi cubic feet. That's in terms of pi, and then rounded. Now, rounded, here's what we can do. Once we have 875, just multiply that by pi, right? Times pi equals. All right, nice and easy. This says rounded to the nearest cubic foot. Now, with a number like this, our closest cubic foot, 0.4, ain't enough. So our closest cubic foot is 5,890, and that's our closest cubic foot. Okay, so that's both answers. All right, so that's the deal with cones. That's the deal with volume of cones. And that's the deal with volume of pyramids and cones. Hopefully this was nice and easy. And stick around. We're going to talk about spheres next. But I hope you enjoyed it. Hope you learned some stuff. Peace out.